Wabarakatuh, salam sejahtera. So this video we covered tutorial 5. Hopefully before you watch this one, you already tried the questions lah. So we start with the objective question. I'm not going to do everything, so I'm just going to select few questions. For question number 4, figure 5.1 shows a rod moving across a magnetic field. Determine the direction of current flow through the resistor. So here you can see the resistor is actually over here. Okay, so since the rod is moving in this direction, you will have a complete circuit like this. Okay, there will be induced EMF inside this rod, and because of that you will have a current that flows inside here. So the question wants you to find the current flow, direction of current flow through the resistor. So to find that one, you can apply right hand palm rule that I use. So magnetic field is actually going into the page like this. Okay, and your velocity is actually to the left, right? So the direction of current on the rod is actually going downwards. So I can write a label here. So inside the rod, the current is moving downward. Okay, but since this one is a complete circuit, over here current move to the left, on the resistor current move up, and then move right. Okay, if the question asks you to find the direction of current in the circuit, you can answer it as if this one is clockwise, but since the question specifically state that find the current flow through the resistor, you need to answer over here. So in this case, it is actually moving upwards, so the answer would be A. So move on. Okay, question number 7B. A circular coil lies flat on a horizontal table. A bar magnet is held above its center with north pole pointing down and released. So initially it is up here and then it's being released. As it approaches the coil, what will happen when viewed at the top? So actually this question they ask you to explain, but I think if you look at the answer, they just simply want you to determine the direction of current. But I'm going to explain it as well. So you have knot pointing downwards. So, right, so the knot is actually pointing downwards. So when the knot is pointing downwards and it is moving downwards, you have another induced magnetic field that will try to oppose those things. So you will expect the induced magnetic field to be in this direction. So knot is upwards. Okay, so when in the top view, this one is actually the magnetic field that is going, sorry, this is the magnet that is going downwards. This is the knot. So trying to oppose those things, it will produce a magnetic field such that the knot is pointing upwards. Dia akan nak lawan, oppose lah. So if you want to determine the direction of current, induced current, you can use right hand grip rule. Knot is pointing upwards, so current will be moving in this direction. Okay, so this direction is actually anti-clockwise direction. Okay, ingat knot tu dia nak jatuh, nak masuk dalam loop. Mana saya punya? So this is your loop. Okay, this is basically like your magnet. Let's say down here is your knot. Okay, since knot want to go inside the loop here, you will have induced magnetic field that try to oppose. Okay, so knot with knot ni paling senang. Kalau magnet paling senang, because nak oppose, knot dengan knot. Kalau nak tarik, south dengan knot lah. So this one not want to oppose, so like this. So the knot is pointing upwards. So you take your thumb, point upwards like this. You can see that this is actually, I think you will see this one terbalik dengan ni because this one inverted. But actually if you do it on your paper, you will see that this one is anti-clockwise motion. Okay. So if they ask you to explain, maybe you can answer knot is pointing downwards, so magnetic field going into the page, and then induced magnetic field trying to oppose. And due to due to change in magnetic flux, you can say that there's a induced EMF, but the direction of current would be according to Lenz's law, which is anti-clockwise. Okay, so question number 8. A magnetic flux of 4 times 10 to the power of -5 is maintained through coil for 0.5 second. Find the EMF induced in the coil by this flux. So if the magnetic flux is maintained, basically the phi dt is equal to 0. So there's no induced EMF, so I can write that one. From the formula of Faraday's law, okay, equals to d phi dt, which is equal to 0. So I just gonna write this one, okay. No change in flux. Okay, question B. The magnetic flux linkage to a coil of wire plays through a uniform magnetic field of 0.6 Weber. If the direction of magnetic field is reversed in 0.1 second, okay, without changing its magnitude, what is the average EMF produced? So you can try to use this one. You can use negative d phi over dt. So they give you the flux. So the flux initial and flux final. You can answer this one as final minus initial. Okay. But since this one is actually they flip the apa yang diubah ni? Magnetic field is reverse. So if you still remember the formula for magnetic flux kan, dA cos theta. So the theta actually represent the angle between B and A. So if you flip, you actually get one is 0 degrees and another one is 180 degrees, which is negative to the initial values. So let's say the value is 0.6, so final would be negative 0.6. So I'm going to write this one as negative 0.6 minus 0.6. Okay. I repeat, they initially in one direction magnetic field. So if the magnetic field is being flipped, the magnetic flux will be 180 degrees. So that one will be resulting in negative. So negative 0.6. And then if you press your calculator, apa ni? 0.6 plus 0.6. Okay, I got here is 12 volt. So the answer will be 12 volt. That one is for question A. Sorry, question B. Now for question number 8C, a rectangular frame of 30 times 20 centimeter is wrapped with a 300 turns of wire. The coil is situated in a uniform magnetic field where the plane is perpendicular to the field. Calculate the magnitude of the induced EMF in the coil when the magnetic field changes from 0.8 in 0.96. Okay, the first thing first, if you get this kind of question, is that I suggest you to draw lah. So I draw it already because nak draw tu ambil masa kat sini kan, so saya draw siap-siap. But if you want to draw, the first thing that you need to determine is direction of plane tu. Okay, so in this question, dia memang cakap specifically the coil is situated in where the plane is perpendicular to the field. So if I want to draw my field to be in, let's say my field is to the right like this. Kalau saya punya side view, this is my field kan. My coil would be like this. Okay, this would be my coil lah. And this is magnetic field. Okay, so the plane is actually 90 degrees. Remember, plane is this one. This is the plane. But the A is actually 0 degrees, if you can see over here. Okay, so if you want to solve that one, you can use again. You can use similar formula, d phi over dt. Okay, and then you have to identify from the question which value that is changing. Okay, dalam ni actually kita ada BA cos theta kan. Antara BA and theta, which one is changing? So in this question dia kata yang changing is actually magnetic field. Oops. Magnetic field in 0.96 second. So I can write this one as negative. I can bring A and cos theta forward because that one is not changing with respect to time. So you left with this, which is actually B final minus B initial. So it will be negative A cos theta B final minus B initial over change of time. Okay. So tak muat, so I'm gonna write it over here. Might put more. Okay. I can try to write it over here. So if I want to solve negative A is actually equals to, mana soalan ni tadi? 30 times 200. And then obviously you have to change to meter. Jadi N, saya tak tulis N tadi. So maybe I can write it over here instead. And okay, so it will be negative 300 turns multiply with the area, which is 0.3 times 0.2. The cos will be cos 0 degrees. Kenapa 0 degrees? You can see from here A and B is in the same direction, parallel. Okay, so the only thing that is changing is actually magnetic field. From the diagram I represent with the lower amount of magnetic field lines ni compared to this part, kan kat belah kanan banyak, so final tu lagi more lah. And then this one will be final minus initial, which is 0 to 0.8. Okay, sebenarnya yang asalnya tak ada, so maybe my drawing is not really accurate. Just write it over here. Okay. The time taken is 0.96. Now you have to press your calculator. Okay, I've got here is actually negative 15. Okay, the negative obviously just indicates the direction. Okay, because this one is induced EMF. But then if you use the formula with the negative value, jangan tiba-tiba hilang, biarkan dekat situ. You don't have to state anything pun. Just write the answer like that. Okay, question number 8D. A wire loop of 18 cm in diameter placed in a uniform magnetic field B 0.6 Tesla. The plane of the loop is perpendicular to the direction of the magnetic field. If the loop is quickly removed from the magnetic field area within 111 millisecond, so the time taken for this process to that process is actually equals to 111 times 10 negative 3 seconds. Initially you have magnetic field is equals to 0.6. Okay, B final is equals to 0 because initially it is in under the uniform magnetic field, and then they tarik, there's no magnetic field at all. Okay, ini sama je macam sebelum ni. So numbers of turn tak ada, so single turn lah, a wire loop. Again, can use dV over dt, change in magnetic flux. So n equals to 1. So it will be d over dt BA cos theta. Okay, using the same concept, identify what is the value that is changing. In this case, the quantity of magnetic field changes, B changes. So yang lain to constant, you can bring that one to the front. So it will be negative A cos theta. Bukan cos phi, cos theta. Cos 0 degrees. And then the magnetic field will be final minus initial over delta t, the time taken. So cos theta equals to cos 0 because the direction of A and B is parallel, And then when you draw, actually saya termiss something because saya dah draw siap-siap. So actually when you try to draw, be careful with direction of the plane. So plane of the loop is perpendicular. So plane dia perpendicular, A dia tu adalah parallel. Kalau kamu fikir dalam otak, dia tak nampak sangat. You really have to draw. Jangan imaginary things. So negative, this one is a circle. So pi r is 18 divided by 2. So 0.09. I changed the meter as well. Square. Final is 0. Minus initial is 0.6. Delta t is 111 times 10 negative 3. I got here is positive 0.138. The unit will be volt. Okay, I think I'm gonna stop here now. Okay, nanti dia lama sangat video ya. Okay, continue do your tutorial, and then after this you can watch the next part of the video. Okay, thank you everyone.